Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.5, day 2, entitled Inverse Trigonometric Functions and Their Graphs. And today we're going to continue talking about the inverse functions. We're going to focus mostly on the tangent function. And just like we saw with our sine and our cosine functions, or the inverse sine and cosine functions, we have to restrict the domain for the tangent function in order to make it one-to-one. And that interval that we're going to restrict it to is going to be from negative pi over 2 to pi over 2. So that is going to be our range values. Now, when we were dealing with sine and cosine, the domain was always from -1 to 1, but the nice thing about tangent is that the domain is all real numbers. So as long as your x value is a real number, then you should be able to evaluate the tangent of something that gives you that number. Okay, so we also have some cancellation properties for the tangent, just like we saw for the sine and the cosine functions. If you're taking the tangent of an inverse tangent, then your x value has to be a real number. And if that happens, you can just cancel out your tangent and inverse tangent. If you're taking the inverse tangent of a tangent of some function of some value, that value has to be between negative pi over 2 and pi over 2. So again, on our unit circle, if we're staying between negative pi over 2 and pi over 2, we're on that right side, the first and fourth quadrants of the unit circle. So it's very similar to the sine function. Okay, and this picture does a good job of showing how if we do the horizontal line test, okay, the tangent function wouldn't pass it if we have a repetitive tangent function, okay, because it's going to hit the function multiple times. So we're going to restrict it from negative pi over 2 to pi over 2. So when we do that, then the horizontal line just touches the graph one time. Okay, so a couple examples here to deal with our inverse tangent and how we evaluate those. Remember, we want to take a look at the number that they give us for x. So here we have the inverse tangent of 1. So this is our x value, and we have to say, okay, is this number a real number? Well, yeah, 1 is a real number. So I can go ahead and I can evaluate this. Okay? So now I'm going to rewrite it just like we did previously. I'll have the tangent of something is 1. So now I want to look on my unit circle, and again I have to stay between negative pi over 2 and pi over 2. And I have to think, okay, where is the tangent? The tangent of something has to equal 1. Now the trick with this is that, remember, the tangent isn't necessarily on our unit circle, but sine over cosine is on our unit circle. So I need to figure out what sine value over what cosine value would equal 1. Okay? So if I go to my unit circle, the sine and the cosine values would have to be the same, so that if I took sine of x over cosine of x, I would get 1. And the only place where that's going to be the same is at square root pi over 2 over 2. Square root 2 over 2 and square root 2 over 2 at this terminal point. Okay? And I want it to be a positive 1, so I'm going to stay in this first quadrant. If I go down here to the fourth quadrant, I still have the square root 2 over 2's, but one is positive and one is negative. So that would give me a negative 1 when I reduced them. So I want this value right here, pi over 4. And again, that's because I have the square root 2 over 2 over the square root 2 over 2. So they're going to cancel each other out to equal 1. So there's a little more of a thought process involved with these tangents here, since you have to think, okay, sine over cosine has to reduce down to whatever value they gave me. So this is my sine over cosine, and when I reduce it down, it has to equal that 1. Okay, so let's take a look at part B now. Again, we want to look at this value that they gave us, the inverse tangent of square root 3. And we have to say, okay, is the square root of 3 a real number? And yeah, it is. It's a real number, so I can go ahead and I can evaluate this. So I'm going to rewrite it. The tangent of something is the square root of 3. So again, remember, I need a sine over a cosine. So I need to think, okay, what two fractions, basically, on my unit circle, if I did sine over cosine, would get me to reduce all the way down to square root 3. So I know I'm going to need a square root 3 over 2, and the square root 3 over 2 goes with the 1/2 in its ordered pair. So I just have to kind of decide, okay, do I want the square root 3 over 2 over a half, or do I want the half over the square root 3 over 2? So in order to get an answer of square root 3, I would need square root 3 over 2 over the 1/2. Because then when I multiply by 2, when I multiply by the reciprocal, the 2's are going to cancel, so I end up with the square root of 3. So that means I need my sine to be the square root of 3 over 2, and I need my cosine to be that 1/2. So if I look on my unit circle, the sine is the square root 3 over 2 right here, and the cosine is the 1/2. So my radian value that I need is going to be the pi over 3. So x equals pi over 3. So it's not quite as straightforward yesterday where we were just looking for sine or cosine on the unit circle, finding that spot, finding the radian. Now we have to think of a fraction, and we have to think of what values in the numerator and denominator will reduce down to equal this value that they gave me. Okay, for part C, now this again is a little bit different because 20 is still a real number, so I can evaluate this. But this means that they took the tangent of something and they got 20. 20 is not on my unit circle, okay? It's not a nice even little section somewhere here in my first or fourth quadrant, okay? It's on there, but it's not a section that we have already marked off. So I'm not going to do this on the unit circle. I'm going to use my calculator. Okay, so we're going to go to our calculator and we're going to do second tangent of 20. Whoops. Now, remember that we have to have our calculator in radian mode. So go to mode and make sure that radian is selected, not degree. And then when I evaluate that, I get a decimal. Now again, that decimal's on my unit circle, 1.5. It's like right about here. It's really, really close to the pi over 2. I think pi over 2 is 1.57, and we got 1.52. Okay, but we went around to 4 decimal places. So my x value will be 1.5208. Okay, so you might see some problems like that in your homework where they try to trip you up and make you think a little bit more. Okay, but if it's not a nice unit that's already sectioned off on the unit circle, then put it into your calculator. Okay, for example 7 here, we're going to take a look at these cancellation properties. And again, if we're going to use those cancellation properties, if we're dealing with an inverse tangent of a tangent, that x value has to be between negative pi over 2 and pi over 2. If it is, then we can just cancel. If not, then we have to go through the whole process. Okay, so here I have inverse tangent of tangent negative pi over 4. So first thing I have to ask myself is that negative pi over 4 between negative pi over 2 and pi over 2? So let's take a look at my unit circle here. Here's pi over 2. Here's negative pi over 2. Negative pi over 4 would be right here. We're going back pi over 4. So it is definitely between pi over 2 and negative pi over 2. So yes, it is between them. That means I can go ahead and I can just cancel those out, and my value will be negative pi over 4. Okay, for part B, we're going to try that same process. Okay, I've got the inverse tangent of the tangent of 4 pi over 3. So I want to see if 4 pi over 3 is going to be between negative pi over 2 and pi over 2. Let's see, 4 pi over 3. Oh, 4 pi over 3 is over here in the third quadrant. Okay, so since 4 pi over 3 is not between negative pi over 2 and pi over 2, then I cannot just cancel. Okay, so I have to evaluate the tangent of 4 pi over 3. So let's go back to our unit circle. Here's 4 pi over 3. Let me scooch just a little bit. And here's my sine and cosine values. So sine is this negative square root 3 over 2. Cosine is the negative 1/2. Okay, so I would need to do sine over cosine. Oop, there we go. So if I'm thinking of sine over cosine, I'd have to do the square root 3 over 2 over the 1/2. They were both negative, so the negatives will cancel. And then the half here and the half here, they also cancel. So if I multiplied by 2, if I multiplied by the reciprocal, the 2's would cancel. So I end up getting the square root of 3. So the tangent of 4 pi over 3 is really the square root of 3. So now this problem is the tangent, or the inverse tangent, of the square root of 3. So that we actually did on our previous problem here. The inverse tangent of the square root of 3. And again, we had to go through and we had to think, okay, what fractions from the terminal points on my unit circle would reduce down to square root 3 over 2. I'm sorry, square root 3. And that was square root 3 over 2 over the 1/2. And where those were both positive was at pi over 3. So here I would rewrite this then. I would say, okay, tangent of something is the square root of 3, and that something is pi over 3. So this one ends up being the same work as we saw in example B, example 6, part B. Now the only other thing that you might see in your homework is kind of a combination of the different functions. Now this is kind of fun, okay? Here we've got the cosine of the inverse sine, or the sine of the inverse tangent. So they're going to mix it up a little bit, okay? So let's just start with our first little parentheses here, the stuff inside our parentheses. I can't cancel anything. I can't cancel cosine and sine, okay? So I'm just going to focus on this first part here. Now again, for our sine functions, remember this x value has to be between negative 1 and 1. So that's my first thought, that 0 is between negative 1 and 1. That was my domain values that I had to stay between. Okay, so that means that I can definitely do this problem. So that means the sine of something is 0. Okay, now if I go to my unit circle, remember for sine, we're looking at the first and the fourth quadrants. We're looking at the right side of our unit circle. So I need to figure out where the sine is 0. And that is actually right here. Okay, remember our ordered pair is cosine sine. So here's 0 in the sine spot. So that's 0 on my unit circle. So x is 0. Now that is what I get for this sine, or inverse sine of 0 part. So really now I've reduced it down to the cosine of 0. Well, now I can just look at my unit circle There's 0 degrees. The cosine of 0 is 1. So that was kind of fun. Okay, we had to apply our inverse function first, and then we did just a straightforward cosine function. Okay, so let's try that again for part B now. We'll get the tangent in there. We've got our inverse tangent of the negative square root 3. So we're going to have to do some thinking for this now. Okay, so I'm just going to start inside the parentheses here with this inverse tangent. We switch colors here. So I have to think, okay, is that negative square root 3, is that a real number? And yeah, it is. It's a real number. It's not imaginary. Okay. So that means that they took the tangent of something and they got negative square root 3. So again, I have to think, okay, what fractions from my terminal points, if I put sine over cosine, would get me square root of 3 or negative square root 3? Okay. So I need to think, okay, sine over cosine. What fractions do I need so that it all reduces down to the negative square root 3? So I'm going to go to my unit circle. And if I'm dealing with tangent, I want to stay, again, on the right side of my unit circle. So I know I'm going to need the square root of 3. I want it to stay in the numerator because my answer is the square root of 3. So I'm probably going to need the square root of 3 over 2 over a half. So I've got sine and cosine. So the sine value is this y value. So right here, if I scooch a little, in the fourth quadrant, this is negative square root 3 over 2 over a half. That would reduce all the way down to negative square root 3. So let me write that down. I want negative square root 3 over 2 over a half. Okay, if I reduce this big fraction down, that's what gets me the negative square root 3 over 2. And now that tells me that my x value is 5 pi over 3. So x is 5 pi over 3. So again, all I've done is this first step. I've just simplified the stuff that was in parentheses here. Now I have to take the sine of it. So now I need the sine of 5 pi over 3. Oh, well then I just go to my unit circle. I find 5 pi over 3, and I look at my ordered pair, and the sine value is negative square root 3 over 2. So for these problems, this last step here with the cosine of 0 and the sine of 5 pi over 3, that should be straightforward. That we've been doing since the beginning of the chapter. Okay? But what they're applying here in these combination problems is dealing with those inverses and remembering your domain and your ranges and how they restrict your function, where you look on the unit circle for your values. Okay, so it's practicing 2 skills in one there. So here's your homework so that you can practice these skills. And remember, I have the solutions worked out in the binder in the classroom. The odd answers are in the back of the book, so make sure you check them. And if you have any questions, come on in and see me before school.